canola soil fertility considerations. I'm a professor of soil science at NDSU. Been there for 29 years. Before that, I had 18 years as a retail fertilizer agronomist and manager of a string of fertilizer plants in Illinois. I got my PhD in '93 and then came up here in '94 when my boss was going to sell the business. So the information that I'm going to talk to you about today, I have just published. The Ag Communications just published the update on the fertilizing canola and mustard, which most people are worried about canola, of course. So I just published that like yesterday. So I don't think there's really any changes to consider, but when you go to the site, it'll say 2023. So if you have an old version sitting on a shelf someplace, just print out the new version. So my presentation is going to go down this road mostly, except I'm going to insert the soil pH some. Our nitrogen rate is capped. That happens in a couple of our crops, and canola is one of them. We find that pushing the yield with the nitrogen rate doesn't work. It's not necessary. Get it enough to have a really good rosette, and the rest is up to the environment. The phosphate, if you're not doing it already, needs to be seed placed or ideally near seed placed because it's such a wimp with the amount of fertilizer you can put with the seed. K-test may or may not be an issue, but the soil test we have, the dry soil soil test with the 1 normal potassium or the ammonium acetate extraction is certainly good enough. You don't have to do any cation balance and all that stuff. That's bad science. You always use sulfur no matter what the soil test says, and go into that in a little bit. And there's no other micronutrients that are important in this region, so don't succumb to fast and furious sales pitches. All right, so before I go into the nitrogen though, and before I forget, I want to mention soil pH. So those of you along the northern tier may not see that this is really a big issue for you. And with soil pH, I mean acid soil pHs of low 5s to into the 4s to, God forbid, but I know it's out there sometimes, into the high 3s, if you can imagine. I mean, that's azalea country, that's blueberry country, but it's certainly not growing canola country. So the acidity in our soils has been there for a long time. When I did a survey of the state back in 1996, looking at some copper problems across the state and nobody knowing anything about copper, I did a survey of the state, went to several places in every county in the state and took samples. And I was surprised how many samples in the, from both sides of the Missouri River from the South Dakota border north until it curves, and then it kind of funnels up through Mohall. There were some acid soils at that time, and I know that the first field I worked with, the site-specific study near Valley City, the pH range in the field was from 4.9 to 7.8. And so these pH variations have been there for a very long time. Brian Jenks struggles with it a lot at Minot because he has huge variations in pH within that Minot experiment station. So, and that affects the performance of certain herbicides, certainly metribuzin being one of them. So zone sample your fields, figure out if you have acid areas in the field, and if you do, you need to treat them. It doesn't appear like canola is quite so susceptible of aluminum toxicity as what small grains are and some other crops, but I was shown a very spectacular picture last year of manganese toxicity in canola, and so it's very susceptible to that. And you know, if you have bare spots in your field nowadays, it may not be because of the salts. It may just be because it's just so acid out there. So the remedy for that is limestone, and probably site-specifically applied limestone, because not the whole field is going to be really low in pH. The problem is the Sydney sugar beet plant is going to close, and so Barry, I think you're still on the call. I think it would be really, really important to get the commodity groups together and try to figure out some some way in order to keep the loading system during certain periods of the year open so that farmers or their suppliers could get that beet lime that's piled up behind the Sydney plant and get it distributed, because as soon as that plant closes, there won't be a loader anymore. But that's the main source of lime in western North Dakota is that beet plant. The other sources are water treatment plants in the various larger cities, the Dickinson, the Minot, Williston. All of their water treatment plants use very finely divided lime to make the sediments fall out so that the water is more pure during their processing. We don't have a lime quarry in the state. So that's all I'm going to say, but it's really, really important. I know that Leo at Minot is doing work on this, and I know for sure that Chris Augustine and Ryan Beto at the Dickinson R&E Center, they've been conducting research down there for 2-3 years, and they're moving ahead on some solutions on how to measure for it, how to soil test for it, how to treat it, the surface application of the lime, so that you don't have to work the ground and watch the soil blow away again. We don't want that. So that's all of that. So nitrogen recommendations are 150 pounds of N in the cooler, moisture areas of the field, and 120 pounds of N, as Jake was saying, in the warmer and drier areas. And those were established by studies that were done in those environments, east and west of the river. And I haven't seen any reason to change them. They're not yield goal based at all. Take a look up at the upper left, and we have, this is probably one of the first indications I had that I really shouldn't be looking at yield at all. And that's at Hettinger, and there was duplicate work at Minot and a couple other places. But the most profitable N rate for the high yielding varieties was the same most profitable N rate as the lower yielding, well, in this case, open pollinated varieties. But that's the same on environments too. That our recommendations of 150 pounds of N, they support over 4,000 pound yields up in the Langdon area, the upper tier counties, when the weather's right and the moisture's right and all the stars are aligned. It's plenty of nitrogen in order to support a crop like that. So you don't push the N rate, and it all comes down to efficiency. When you have a poor year because of dryness, there's not as much nitrogen being released by the microorganisms. And there's the root systems aren't nearly as wonderful. And the mechanism that nitrate goes to the roots, which is mass flow, which is the plants produce a moisture deficit around the roots, and then the water moves in to replace that low deficit, because that's just what water does. It's carrying the nitrate dissolved in it. But when the soil's really dry, there's no mass to flow, and so the efficiency of any nitrogen that's in the soil is just greatly reduced. And so it takes far more nitrogen, or really any nutrient, to make a crop in a poor yield environment than it does in a normal environment. And so, talk about yield goals at all. Change your yield. If you think you're going to get 4,000 pounds, you don't up the 150 pound rate in order to reach it. It's already there. You've got plenty. And what's not there and what's needed in a good environment that's going to support 4,000, the microbes are going to be working overtime and producing nitrogen in their own with their asymbiotic bacteria. And that's especially true with no-till, which is, no-till, purest no-till or one-pass seeding. Some people are confused about that, but as long as you're only tilling within a couple inches of the surface, you get that asymbiotic activity. You don't have to buy it in a jug. It's already there. It's been around for 1.5 billion years, so it didn't come out a couple years ago. All right, so that's that. So we use the Olsen phosphate test, and when you have lower than high soil test readings, which high would be 12 to 15, then some phosphate needs to be applied. Canola is a non-mycorrhizal crop, so it really, really, really likes either seed placed or near seed place. There's no mycorrhizal fungi, hyphae, little tiny fungal roots to help it out. So it has to have it close to the seed. So if you're broadcasting, you're leaving a lot of canola on the table. You need to figure out some way to band it. And ideally, you need to band it so that it's a little bit off to the seed. That way your flexibility with what rate you can use is a lot better. Potassium, most of you are going to be okay, except in the very, very, very sandy areas. And there's not that many of them out west. So I anticipate that most of you won't have to worry about potassium. So this is the difference between banding with the seed and not banding with the seed. Let's see, where's the laser pointer? Right there. All right, so this is some old work from Manitoba, but it's still valid. These are the yields in bushels an acre, and I think a bushel is 50 pounds, if I'm not mistaken. If it's not, forgive me. But here we got the rate of P2O5 per acre, going from 0 to 108, which you would dare do that if you band it with the seed. But see, we're getting yields of about 32 bushels an acre with that really, really high rate. What is that? That's 200 pounds a map per acre. I think that's right. If we're banding with the seed, see what happens. I mean, you're okay up to about 75 pounds of, at least in this case, at least in this work, is probably medium textured soils. You're okay up to about 75 pounds or so, but then the yields drop off because the fertilizer begins to be harmful to germination, and the yields go downhill. But in a banded, where it's separated from the seed just an inch, you're getting yields when you get up to maybe 75, 100 pounds a map per acre or so. That eclipse, by what, 50% more yield by banding it than you would with broadcasting it. We see the same thing in sugar beets, which are also not mycorrhizal supportive. So if you're not banding, I mean, it's a glacier out there right now, so there's still time to rig up your planter so you can do this. So the thing that's going to interfere with whatever you decide to do is how your planter is rigged up. So we see here, if we have just a disc or a knife or something, 6-inch spacing, 9-inch spacing. If you have the sandier soils, you're really restricted to how much you can have. And most of you have variable soils where you might have some sands up on the hills or sands in the ridge someplace or so. So you just really have to watch yourself. This is pounds of nitrogen plus K2O. The sulfate doesn't enter into it at all. The anion doesn't enter into it at all. But the ammonia certainly does if you're using a 1034 based product or quote unquote low salt that's just as harmful as the 1034 base because of the urea that's in it to make the nitrogen component. So in a medium textured soil, which most of you have, you can put up to what, 5 pounds of N plus K2O, which would be what, 40 pounds, 40 to 50 pounds of 1152O with the seed. And when you start to go to seed spreads, 2-inch seed spread, sweep, somebody asked on the chat or the Q&A earlier today about what about seed spread. So if you're spreading seed and fertilizer, you can go to higher rates, but you still have to watch it. This chart is in that circular, so pin it on the wall and follow it. When it's moist, you can cheat a little bit, but if it gets dry, it's going to burn you, literally. So I just want to pass this along. Ed Dibert did the original work in North Dakota on sulfur. And I think it's because of his work up at Rock Lake that a lot of people didn't get burned in 95 or so when they started to move toward canola production. If we wouldn't have had his work, I think people really wouldn't understand how important sulfur really was. But he was an incredible person, very humble. He's responsible for all of the seed with small grains circular, all those vast numbers of charts and stuff. His work was meticulous, and it would exhaust me to try to do the kinds of things he did. So it's sorry that he's done. So he did a series of experiments up in Rock Lake, and it's my favorite sulfur experiment of all time. So he worked on a landscape. So he had a Buse on the hilltop, a Barnes on the slope, Svea on the foot slope. So with 0 sulfur up on that Buse hilltop, you got 30 pounds of canola per acre. But when he put on 20 pounds of sulfur as ammonium sulfate, he increased the yield. What is that, 5,000%? I told Ed at the time, I said, if you were living 1,000 years ago, you'd be the court wizard and you'd have a gold chain around your neck. But I think he got a cup of coffee here at NDSU. So it's really, really important. See what happens when you don't have it, and see what happens when you do have it. Is elemental sulfur helpful? I mean, it's not nothing, but it's not this. So don't use that. And there's no situation that I can consider where elemental sulfur is going to be helpful for you. So just don't even consider it. Ammonium sulfate, I noticed that one of the experiments had potassium sulfate. It's not a common fertilizer, but if you want to reduce your acidification from your ammonium sulfate, person, if it's available, potassium sulfate be a perfect source. But it's not commonly available except in potato country. So with that, I don't want to say this is easy, but it's pretty straightforward. The work was all done by NDSU scientists and Canadian scientists when they actually had people out in the field before they gutted it about 15 years ago. So our nitrogen rate is capped at 150 pounds of N per acre in the east and 120 pounds of N in the west. Langdon area might be able to shave that a little bit, but I don't think I'd get too rammy about it. If you're 20 pounds more than you really need, because that Langdon soil has a slow release nitrogen component in it that John Lukatch's work didn't support really shaving that rate very much because of the kind of soils. But the yield potential in an area is just so high that that's probably why we haven't really seen it. So I don't think I'd take that 130 nitrogen per acre to heart. I'd go more with 150. Greater nitrogen rates won't increase your yield potential. Yield potential after the cap is applied is due to the weather. Apply banded P, pay special attention to with seed N and K2O. Always apply your sulfur as a sulfate or thiosulfate source, and avoid miracle products, because most miracles don't happen except in the Princess Bride. So with that, I think I'm done.